Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this rational function inequality. The given inequality is 5 over x plus 3 less than or equal to 2 over x plus 1. The first step is to move 2 over x plus 1 to the left side of the inequality so that we have only 0 on the right side. For that, we should subtract 2 over x plus 1 from both sides. Next, we should combine these fractions by finding a common denominator. The common denominator is x plus 3 times x plus 1. We should multiply the first fraction by x plus 1 in the numerator and the denominator. And we should multiply the other fraction 2 over x plus 1 by x plus 3 in the numerator and denominator. Next, we can combine these fractions into a single fraction. Next, we can distribute the numbers into their respective parentheses. Next, we can combine the like terms in the numerator. 5x minus 2x is equal to 3x. 5 minus 6 is equal to negative 1. We have to find the x values that satisfy this inequality. Next, we should find the x-intercept and vertical asymptotes for this rational function. For x-intercept, we should set the numerator expression equal to 0 and solve for x. I get x equals 1 over 3. Next, we can find the vertical asymptotes. We should set the denominator expressions equal to 0 and solve for x. The first vertical asymptote is x equals negative 3. The second vertical asymptote is x equals negative 1. Next, we can use the number line method to find the intervals of x over which the inequality 3x minus 1 over x plus 3 times x plus 1 less than or equal to 0 is satisfied. We can start by drawing the number line. We can show the x values for vertical asymptotes and x-intercept. These three values divide the number line into 4 parts. We have to use a test value for each part of the number line. On the left side of negative 3, we can use the test value negative 4. Between negative 3 and negative 1, we can use the test value negative 2. Between negative 1 and 1 over 3, we can use the test value 0. To the right side of 1 over 3, we can use the test value 1. We have to sub in these test values one by one in this inequality. We do not need to do the test for negative 3 and negative 1 because at these x values, the inequality becomes undefined. However, we should do the check for x equals 1 over 3. Let's start with the first test value, negative 4. We should sub in x as negative 4. I get a negative value, which is less than 0. That means the inequality is satisfied in the interval to the left side of negative 3. Next, we can use the test value negative 2. I get a positive value, which is greater than 0. Therefore, the inequality is not satisfied between negative 3 and negative 1. Next, we can use the test value 0. I get negative 1 over 3, which is less than 0. Therefore, the inequality is satisfied in the interval between negative 1 and 1 over 3. Next, we can do the check for x equals 1 over 3. In the numerator, 3 times 1 over 3 is equal to 1. 1 minus 1 is equal to 0. In the denominator, we'll get a positive value. So the overall value will be equal to 0. Since the inequality is less than or equal to 0, that means we have to include the endpoint 1 over 3 in our answer. Next, we can do the check for test value x equals 1. In the numerator, 3 times 1 is 3. 3 minus 1 is 2. I get 1 over 4, which is a positive value. It is greater than 0. That means the inequality is not satisfied in the interval to the right side of 1 over 3. Now we can write the solution for the inequality. We can write the solution in inequality notation as we can write this solution in interval notation as this should be the final answer for this problem. These are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.